guys. You might be new faces to some of you. My name is Scott. This is Weston. We're part of the new board, which also includes Catherine and Jenny. Wes will also be staying on the board. And we are here to present to you the hardware in gaming with Jon Leek, who has been so awesome to lead this. We don't really have much else to say to start, so Jon, you'd like to take it away.
Cool. Yeah.
And then afterward, we will recap with our upcoming events. There's at least 5 events that you can know about. So, take it away, Jon.
Nice. All right. Yes, I'm Jon. Well, you guys probably know me. I've been making games since 2009 or so. Playing a bunch of the game jams. I do stuff. So I've always liked things, right? Like, I grew up on the DeLorean and the Batman's utility belt, Proton Pack. When all the other kids wanted to be James Bond, I wanted to be Q, right? Because Q, like, James Bond had some cool toys, Q had all the cool toys, right? So it's only natural that this would kind of like spill over into my game design, and eventually, like, it's something I wanted to do for a long time, but I was working on a startup and like eating pennies, and like I just couldn't afford it for a long time. Got a big kid job, could finally start afford it in the last couple of years, and I basically lost my mind, as evidenced by the table in front of me. So I want to kind of walk you through like that process of like how I got into it, how you can get into it. We can talk about some of the projects that I've got on the table, some of the stuff that isn't on the table that I'm working on, whatever. I want this to be very conversational. So if you have any question, ask it. If you want to play with something on the table, just like come up and grab it. Just give it back. Like, part of the reason I love this is the tactile nature of it, right? Like, I like that I can now, through this, not only can I make it like a cool game, but like the controls can be exactly what I want them to be, because I can go and I can pick out the buttons. And if I don't like the buttons, I can rip the buttons open, and I can replace the springs. I can file stuff down. I can like whatever. So normally in a talk like this, we would start with a basic conversation about like electronics and like the relationship between voltage, current, and resistance. Dirty secret, guys, you don't actually need to know this in order to start doing any of this stuff. It helps. Eventually you will want to learn it, but to get started, totally don't need this, all right? You also don't need to learn how to read these big, scary schematics. These things are awful. I still don't know how to read these. I know it's this is a switch, I think.
Transistor.
See, I'm wrong. I don't know what I'm talking about, right? But yeah, so like I don't even know what this is for.
That is a good question.
Yeah, so what you do want to learn and what you want to decide pretty early on, especially if you're just getting into this, is what road you want to go down. There are 2 big platforms that kind of drive this movement of like custom electronic nonsense. Unless you truly hate yourself and want to do it with just transistors and switches and buttons, more power to you. You're gonna start with one of these 2 things. Starting on the left, Arduino is an open source platform of microcontrollers. So if you're not familiar with a microcontroller, it's like less than computer. I've got an example of an Arduino in one of these boxes. Oh, here we go. This is actually an Arduino Mega under here. Come out. So what you get is like a very simple little board, and at the heart is a microcontroller. Microcontroller is a programmable chip that can run very basic code, but it does not have an operating system in the traditional sense. It does not have like storage and RAM are kind of the same thing. It's just like however much space there is on the chip. You can add more if you want. I've never like gone down that road, so I can't really help you much in that regard. But these are super cheap. I think this was like $10 on Amazon for this one, and this is like the beefed up version that could like power like a pinball machine or a 3D printer. This is not the cheap. The cheap version of this is like $6 or $7, less if you're willing to go on eBay and order from China. These are great for very simple, specific things. If you want to drive a screen, you probably don't want to mess with these. You can, depending on the type of screen. But like if you want like an LCD video game, you're not going to have fun with this. This is the kind of technology that like Pac-Man was built on. And if you've ever read about like the programming that had to go into like Pitfall and Pac-Man to make those games work, you will hate yourself. It's awful. The entire world of Pitfall, like the original Pitfall, was one 8-bit string. Like one 8-bit character was like defined the entire world. Like he had to figure out how to do that because this is the kind of stuff they were having to deal with. So if that's scary to you, and it shouldn't be, it sounds scary, but it shouldn't be. It's actually pretty easy. I actually prefer those over these. So the other is Raspberry Pi. And the Raspberry Pi is, simply put, a very tiny, very cheap computer. This guy here is 5 of those networked together in a handy little lunchbox case. And those are the expensive ones. They go all the way down to, if you get the Raspberry Pi Zero, you need some extra cords and stuff because it has like weird mini HDMI and USB on the go, like it doesn't have proper USB ports and stuff. But they're like they're in a bin. They're $5 a piece at Micro Center, and they actually charge you more the more of them you buy. Like if you buy one, it's $5. If you buy more than one, it goes up to 10, and it goes up because otherwise someone like me would go in with a trash can and buy all of them. So these are more like traditional programming. Typically, you have these running some form of Linux. You interact with them via either a command line or a graphic user interface. There are some little nuances. You don't have a hard drive, you've got an SD card. But other than that, like if you're comfortable with a computer, which most people in this room are, you can deal with these. The thing that's nice about them is they have pins on the side where you can hook sensors and things. They're frequently used in robotics, that type of stuff. Anybody who's ever used like a RetroPie, the cheap little like play all the video games ever made box, based off of these guys. So when I got started, I knew I wanted to get into this, and I knew programming wasn't for me. Like I've struggled, and I've talked to many of you about this before. I struggled with programming. I tried a lot of different languages. I tried a lot of different ways to learn. It just never friggin' clicked. So I knew I didn't want to go down this route because I already had a computer. And I couldn't program it. Why would I be able to program one of these? So I went with this, right? So this was the kit that I bought. You can get this on mono price for $50. I checked last night, $50. And it comes with just a bunch of nonsense. Wires and LEDs and just all the stuff you need to start with projects. Everything's nicely labeled and in bags. You got your Arduino, you got a proto shield, we'll talk about shields in a minute. But you got like battery holders and motors and fan blades and resistors and LEDs and potentiometers and relays and buzzers and all kinds of fun stuff. This is the key. This is why I like this kit. This is why I recommend this kit to everybody. So those schematics, those sucked. This set comes with schematics that look like this. So instead of getting a diagram that you have to understand what the symbols are supposed to be, they just show you where to put things, right? Stick things in these holes, magic happens. And you can go and you can download the code, so the code's already there, and you can kind of get started. Anytime you're trying to learn a new technology, there's like that delicate balance between like, I need good documentation, but I need the tutorial not to be too hand-holdy or I won't actually learn anything. This is great because this whole kit was made by some company in China. They have excellent documentation, but I can't read any of it. But I could follow these, and the computer code was in English. So I was able to go in and I worked through the entire kit. I think it's 16 projects, worked through them in a night. Just plowed through. The first one was just like, make a light blink. And then by the end of it, you're making like fan, like adjustable fans and like a little working traffic light that changes red, yellow, green, and back, and what have you, based off sensors and all kinds of fun stuff. So that's kind of how it started. The beauty of it, and the thing that makes this truly special is like once you have this, I very quickly just decided, hey, I want to make a thing that's not on any of these cards. But this one tells me how to wire up a button. So I know how to wire up a button, so I'll wire up a button. And then this one over here shows me how to wire up an LED. And then I can just go in the code and I can tell those two things how to interact the way I want them to. And I have example code for how to do that. I know how to make an LED do whatever I want. I know how to receive the signal from a button, merge those two together. Boom, I have a button controlled light. Perfect. It's ridiculous how far I've been able to go with this stupid rip things apart and slap them together methodology. This is like a huge part of programming in general, but like especially with this type of thing, this suddenly started to click, and suddenly I started to learn how to program. So what does the programs that run these things look like? So if you're getting into Arduino, Arduino has its own IDE that you can download. It's free and magical. This is the code for those of you who were at the last Global Game Jam. We made that horrible Screechy Box game, right? Like super annoying one that nobody wanted us in their room. This is the code for that. So some of this is really scary. Most of it's not, right? To start with, you have just an area where you just define things. Be like, okay, when I say target R, I mean 11, because all of the little pins where you hook up wires, the little holes, have numbers. That's where I'm going to plug the light in. Like the target red light goes to 11. Target green light goes to 12, blah, blah, blah. Then we learned a thing. We learned how these arrays work. So instead of the controller pins, instead of individually addressing them, we learned how to do it all at once, which is great. We learned something. Did the same thing with controlling the player's light. So then we set like what we want some variables to start out as, blah, blah, blah. Find some things, find some things. Then we get to setup. So Arduinos are weird. Arduinos are like really dumb, guys. They're single threaded. So if your instructions have something that take a long time, your Arduino's just going to kind of stop and do that thing. And it's not going to be able to do anything else while it waits for that thing to figure out that thing. So you have to be kind of careful about that. But what it essentially does is as soon as you give it power, there is no like start button. Like you just, as soon as you give it electricity, it goes through the setup, and then it just does whatever you put in this loop over and over and over and over again until you like deprive it of power. There is no off button, you just like rip it out of the wall. So for us, the setup involved like defining, so we said like, okay, this pin goes, like this hole goes to like the LED, right? So we need to tell it like, okay, so that pin is an output, because each of those holes can be an input or an output, depending on what you want to do with it. So we gotta tell which we're doing. So we did that for a whole bunch of stuff. Then there are libraries which we set up way up, back up at the top. So like any other programming thing, I thought we did. Maybe we didn't use any. But there are libraries to like expand stuff. So like most of the things, like if I want to mess around with like a liquid crystal display, like those cheap ones that are like at the top of calculators, somebody else has written software to physically interface with that deal so that I don't have to figure it out, which is awesome because those things are a huge pain. There is a great video of a guy who figured out how to like interact with those with just switches, and it's mind-numbing.
We'll post it somewhere.
Yeah, it's great, and you can learn a lot, but it's mind-numbing, right? So you can just install that, and then use that to call different functions without having to, it's kind of hard to code this stuff yourself, right? So, so the setup, we do some of that. We have it random seed, so Arduino has like a pseudo random table, but unless you want your game to be identical every time, you need to give it a random seed. So this is great. The random seed is reading an analog signal from just a loose wire that it just kind of like plugged in and left dangling in the breeze. And it's so it's taking a random seed just from like whatever random electrostatic interference is in the air, right? And then we call some functions that we define way down below, right? So it gets ready for the game. It makes some pretty noises, finds all its bits, figures out what's going on, and then it just does the loop. And we're not going to go through the whole code. It's not terribly long, but it's longer than like you guys probably want to sit here and just like listen to me talk about. But the gist of it is that it is constantly going through a loop of reading the player's controller. Each player has like a dial, right? So it reads that dial, figures out what number it's set to. It makes their LED match that number. So if you're the blue player and you set your dial to 237, it's going to set the player's light to blue 237. And through that, you collectively control one RGB LED. It then compares your numbers to like the target numbers, because there's a target light that has set values to it. If you are within a certain range, it makes a bunch of happy noises, gives you a point, and then randomizes things. Otherwise, it just keeps going through that loop over and over and over again until those conditions are met. Just over and over again. They're great, they're super dumb, super easy, right? So that's an example of like just a game you can make with these. It was a lot of fun. We learned a lot making it. Yeah. So, yeah.
I have a question about the random seed. What does that go between, like, what values?
I have no idea.
And usually, if it's anything like seeds, it'll take any.
Yeah.
Okay.
No clue. So now that like I'm starting to build stuff, and at this point, like I'm starting to build some other projects. I'm building a thing for my brother's anniversary. I'm going nuts, right? So this is a great start. But then like you start wanting more stuff like this. So like I bought a couple of these. Like I bought this starter kit, but I also bought the Arduino official starter kit, and like I bought like 3 or 4 different starter kits, so I get a good range of just stuff, right? And I ended up with like 3 or 4 of these Arduino boards to mess around with, so that if I fried one, it's no big deal. By the way, as you get through this, these all work off of like USB power. So you're not going to electrocute yourself on this unless you do something like truly stupid, right? Like less than a 9-volt battery these run off of. Another thing I started doing is I joined like the subscription box thing. So Adafruit, which we'll talk about in a little bit, they've got like one of these like Loot Crate, right? You pay them $60 a quarter, and they send you a box of fun toys, right? And so I started getting exposed to other stuff. So at this point, I learned that Arduino is not just a company. Like they are a company that makes all this cool open source stuff, but because it's open source stuff, you have other stuff that plays with the system that isn't made by them. So a great example is this guy. So this is a feather. Adafruit has their own system of stuff that is Arduino compatible. So we program this the same way we do any other Arduino thing, but they make their own things. So this is unlike any other Arduino, but it's called a feather. This is specifically is a feather huzzah. So instead of based off of a microcontroller, it's based off a little wireless chip. So it has internet, which is awesome, because now I can make wireless, like creepy wireless stuff. And this box came with like an assortment of stuff. This one came last week, and it makes an MP3 player that works. Like I made it last night. Not a terribly exciting MP3 that came with the kit. And I was too lazy to upload another one, but hey, it beeps. Cool, right? Now, I bring this up, it's a good way to start getting exposed to, like, thanks to this box of stuff that shows up, once every 3 months. I've gotten a bunch of parts that I probably wouldn't have bought otherwise. I've got like a little thing that's got an e-ink display, which is neat, and I like messing around with. Probably wouldn't have bought an e-ink display if I had just seen one on the shelf, especially not the size, because the thing's like the size of my thumbnail. But now that I have it, I'm playing with it, I'm tinkering with it. The other thing that's nice is that Adafruit documents all of their stuff really well. So once I got this box, I just went to the website, and they explain how the feather works. And then they explain, this is a good time to introduce stuff that stacks on tops of other things. No matter what way you go with this, Arduino, Feather stuff, Raspberry Pi, all of these systems have stuff that stacks on other stuff. And they all name it something different. With Raspberry Pi, they call them hats. Arduino, they call them shields. Feathers call them feather wings. But it's this thing that just really handily plugs into the top. And all the circuitry is already done, right? Like I had to wire in this speaker, but this has an SD card slot reader in it, and it's got a little chip that can decode MP3s, so I don't have to figure, like I don't have to mess with that. And there's like a whole library that supports this, so I don't have to figure out how to program this thing. I can pretty much just get going. This is a hat, or no, not a hat, this is an Arduino shield that fits like a standard Arduino board. Just a bunch of LEDs, makes pretty lights. Everybody loves pretty lights, right? Explains how to get those, and I walked you through a couple projects. So like, this was just the first like, hey, make it do a thing. But like the next project is to start streaming internet radio over this crazy thing that I made. That sounds like fun. I'm gonna look forward to doing that. And in the process, I'm gonna learn a bunch of stuff about like how internet radio works. Doing this kind of stuff, I've learned how GPS works. GPS is terrifying. I've learned how these NeoPixel things work, which are amazing and so much fun. They're a good way to kind of get started. They give you good instructions, and just like that original kit, it's a good stopping point to be like, oh, well now I know how their stupid little shield works. How about just the big strand of LEDs that's based off the same technology? Like it's the same LEDs, just like in a rope, and without a board, so I have to wire it in myself. Okay, and then you can get that up and running, and it takes like, an hour or two. So as it starts getting going, there's like a few like tools and things you should probably learn about. One, probably the most important, is the solderless breadboard. So most of your projects early on are really temporary things, right? Like when I'm going through that starter kit, I'm building a thing, I'm getting super ecstatic because the light lit up, then I'm immediately ripping it apart so I can build the next thing. If you're soldering that stuff together, A, you're messing around with the soldering iron. These things get really hot. But also, like, you're having to undo all of those solders every time you want to change something, right? And if you mess something up, like, it's a hassle to change. These changed all of that. So, solderless breadboard looks like this. Board with a bunch of holes, right? There's a channel down the middle, and these two, like, scrapes down the side. So the way it works is like these holes are all connected. So if I plug something in here and plug in something here, it's as if those two things are connected by wire. Because essentially they are. There's like a little metal plate underneath that does that, right? And then these guys up and down on this side, on each side, are connected. So like everything by this red line, this whole line is all connected. This whole blue line is connected. But nothing crosses this gap. And so by doing this, by using this, you can start to assemble something like this. So that Arduino Uno that we talked about earlier, like the really simple, like $7 thing, this is what they look like if you make them yourself. It's a microcontroller chip, just an integrated circuit chip. This is the most expensive part of the thing. You can buy them by like the case. A clock, so that it looks just like a simple crystal clock, so it's got a system clock. And a switch and some voltage regulation stuff and some LEDs so you know it's working, and a reset button so that if you bork it, you can make it start over. So this is most of your starting projects, and most of the things that you make will at least start like this. Just plugging stuff into little holes, seeing how it goes. There are a couple of big differences from those of you who do like traditional video game design, which is most of you like traditional programming. There are a couple of things that you should be aware of. One, debugging this stuff is a little more difficult than debugging just traditional software, right? Because I don't know if it's a software problem or if it's a hardware problem. And more than that, most of the time when something doesn't work, you get like zero feedback, right? If I'm making Mario, and Mario jumps through a block, that gives me some information about what is wrong, right? Oh, the collision box detection is not like working. He needs to it's not detecting that hit, right? Usually, what'll happen with something like this, one of two things will happen if you plug it in and it's wrong. One, nothing will happen. It will just lie there. Or two, you'll see some magical blue smoke, which means you broke something. Congratulations. Luckily, all this stuff is super cheap. So once you build these things for a while, and you start getting like, well, I want to mess with something a little more complicated, like those LCD displays that we were talking about earlier, right? I want that, so I can have a point counter. And then you do that the first time, and you realize that it is awful. This is my first project that did that. All of this wire nonsense and all of this soldering and then dremeling is me trying to get this LCD to work because I don't know what I'm doing, right? So I'm going to introduce you to a breakout board. So on this same circuit, I have a GPS breakout board. So GPS works, there's an antenna and there's a receiver, and basically it's a chip, right? That knows how to take this signal out of the air and turn it into a string of scary numbers and characters and what have you. Those chips are kind of a pain to work with. They are surface mount, which means instead of having nice little pegs that go into holes, they just kind of like sit there and you have to solder them in, and they tend to be really tiny and awful to work with. But also, like, there's a bunch of, like, the chip has to have a bunch of, like, voltage regulation stuff and, like, other auxiliary systems to support it, right? So people sell these breakout boards that have all that auxiliary stuff kind of baked in so that it's easier. So now, if I want to use this LCD display, instead of, like, trying to wire this in directly, I get a breakout board, and instead of having to wire in, like, 30 things, I have to wire in like 5, and a lot of that background stuff is taken care of for me, which is awesome. This is what's going to let you deal with a lot of your more exotic stuff. GPS, wireless, near field communication, Bluetooth. I've got breakout boards for all that kind of stuff. Photo gates, which are really cool. Super simple, but really cool. Yeah, so now you're starting to get a project that looks kind of like this, right? You've got a breakout board, guy just kind of shoved it in, he's got the wires all set up, got the Arduino. This picture did not blow up as well as I'd hoped on TV. And it's all powered off a 9-volt battery over here in the corner. And cool, so you do this and you're like, hey, what I made is really neat. I want a permanent version because this is This is the first version of our Game Jam game. I don't think it works anymore. Because all it takes is one of those wires to come out of the hole and it doesn't work. And it doesn't work in a way that's really hard to diagnose, right? Or if one of those parts fails, like who knows, or like it just pops out. Like there's like a billion things that could go wrong with this. This is scary. Won't take on an airplane. So next, you start soldering, and this is where you start soldering. And this is the thing that freaks a lot of people out, right? Soldering seems scary. It is not. I brought my rework station to kind of show you guys this, like what it is. I'm not going to solder here because it puts out fumes, and also like I don't want to like set Ryan's office on fire or burn myself in front of you because that would send the wrong message. But this is like a really fancy rework station that I got. But basically, you've got a metal bit that gets hot, right? And then you've got a special type of wire that I thought I brought, but I didn't, called solder, that melts at a low temperature. So you stick the tip against the perf board, like this stuff, right? The little foil pad there. And the piece that I'm working on, like I want to attach at the same time. And both the whole system kind of heats up. The pad gets hot, the part gets kind of hot, and then I introduce the metal. The metal melts almost instantly, and when I pull this out, it cools almost instantly, and your part is securely attached, and you snip off whatever little bit of wire is left, and you're good to go. Very easy to do, very hard to do well, but the good news, you typically don't have to do it very well in order for it to work. And that way you can start making more permanent things, attaching stuff to other stuff in more permanent ways, and your projects start to become like that little bit more real. And then you start putting them in enclosure boxes and making them look pretty, and like you just lose your damn mind, and next thing you know, you've got like half your apartment is filled with this nonsense, right? So, are there any questions about anything I talked about so far? This is kind of a lot. Cool, so you want to get started. First off, where do I buy all this craziness, John? So, there are three main places that I go to, I guess four if you include Micro Center. Micro Center has some stuff, their selection's not great, they're good in a pinch. They carry all the basic Arduino stuff, so if I just like realize I'm out of Arduinos, I just go and pick up another one and I'm good to go.
Great for Raspberry Pis.
Same for Raspberry Pis.
Yeah.
But the three main places I go to, Adafruit is awesome. Adafruit is a little overpriced, but you're essentially paying for documentation. And I want to support them because of that. So I can afford it, I just give them all of my money. Any part I buy from them, I know that they're going to have like a full-blown tutorial and probably a cool video and some example projects. It's awesome. SparkFun is like the next step down. SparkFun provides some documentation. They tend to have more exotic stuff. They really specialize in like robotics. So like when I needed a photo gate, which is just like an infrared laser that you can sense when it's been broken, Adafruit doesn't carry those. SparkFun carried them. So that's usually where I'll go if I find something else that like I need. But and then finally, if I want something really specific or I don't know what I want, these are photos from a place called Gateway Electronics out in Creve Coeur. Gateway, this place is awesome. If you've ever been to like a scrapyard, you think that like that's your type of place, you'll love this. They've got bins of just like switches and buttons and levers and lights and like whatever. They're great. I almost anytime I'm building anything and I want to pick out the controls, I go there because I can actually feel like, okay, this is what that switch feels like, because that's really important to me. I typically don't care about how much power it's designed to withstand because I don't do any high power projects. As long as it works and I like how the button feels or the switch feels, I like the way it clicks. That's what's important to me. So I go there because I can do that. They are also great because in the back of the shop, they have a bunch of electronic salvage. So radio stations that upgrade, TV stations that like upgrade or go out of business or whatever, their stuff just kind of ends up at this place in the back. And you can buy it for super cheap. And this is great because if you get the rework station, it comes with, this is a hot air gun. This is probably the most dangerous thing that I own. Surprisingly, right? So far I've gotten this spitting out air at 450 degrees Celsius. And it got up to that temperature in about a second and a half. To put that in perspective, I originally had the mount for this. I put it in like this instead of like this, because every other thing like I've ever placed in a holder, it goes point down, right? When I put it like this, it very quickly melted the top of my plastic table. Like my trashy plastic folding table that I use for this type of stuff because I need to be okay with destroying it because I do stupid stuff like this. But once you get one of those, I don't even buy stuff from these guys anymore unless I have something really specific I need. Now, when I want like these cool slider deals, I go on eBay or Craigslist, I find some guy who's got a broken audio mixer that I can buy for $5. It shows up in the mail, I get all excited, and I spend a Friday night using that hot air gun to melt that solder, and then I just shake it, and all the parts fall out. And I can get like $100 worth of parts from like one $5 thing because it's broken. And nobody wants it. And so that's how I get like the majority of my parts now. It does lead to some interesting things. These slider things don't play nice with breadboards. They're like, posts are spaced in a weird way. They don't fit, so that sucks. But I'm getting exposed to all this stuff. I'm now getting like really big, scary capacitors. out of things and all kinds of fun stuff like that. So, so that's one place to go. If you want to learn this type of stuff, there are three, in addition to going to Adafruit and reading their documentation, that kind of stuff. If you're looking for inspiration and for learning, three main places I would go. So Adam Savage from the Mythbusters actually started this before Mythbusters, but now it's like his full-time thing since Mythbusters is not a thing. Has a YouTube channel called Test It, where he just makes usually movie props and costumes, but they will occasionally do electronics stuff because they'll want to make, a Mass Effect rifle that lights up and makes noises. Or what I really want to make, they made a Ghostbuster trap, and when you stepped on it, it opened up and lit up, and smoke came out and made noises. And then when you pressed it again, it would close, and the little occupied light would start flashing. I fell in love with that thing. I'm going, that's the reason I bought a 3D printer, so I could make one of those. So that's a cool spot, and it's a good place to see how to make stuff outside of the electronic side, right? Because making all these electronic stuff is cool, but as many of you have commented, it looks like I make bombs. It's just nothing but wires and weird, crude things, right? If you want a more finished product, you need to learn how to make a special box. You need to learn how to make that box look weathered if you want to give it a personality. If you're making a game, if I'm making an electronic version of the Jumanji game that has an LCD screen in the thing in the middle so that as it rolls the pieces move around, if I want to truly capture that, which they did on Ben Heck's show on YouTube, you also, in addition to getting all the electronics right, you have to make that wooden box, and you have to beat it to hell just the right way so that it looks like the Jumanji box, right? Adam does that kind of stuff really, really well. Colin's Lab, another YouTube thing, this is put out by Adafruit. This guy talks really slow and his speech patterns really bug me. But each of his shows, he will talk about one thing. He'll be soldering, here's how it works. LEDs, here how they work. And he will just go and he'll talk to you from a very basic, physically, here's what's going on, and how to use it. So it's a great way to get that introduction to what the hell is a potentiometer, right? I've used that term a few times this night. Most of you probably have never heard of it and are what is a potentiometer? A potentiometer is a dial. It's just a dial. It's just a variable resistor thing. So that's cool. And if you just need inspiration, Hackaday. So you know how the internet allowed us to find all the crazy people, right? And now, no matter what you do, there's one crazy guy who's taking it to some crazy, ludicrous extreme. That's Hackaday. The last cool thing I saw on Hackaday was a guy who's building a full-blown programmable computer from this type of stuff, breadboards and wires and resistors and capacitors, no integrated circuits. He's doing it all from scratch, right? That is insane. But he's already got it working. And so people post their projects, right? They'll post the crazy robot they made. They post, and usually there's YouTube videos, there's links to posts about it, blog posts will be yeah, I talked about this crazy thing that I built. Really cool site, lots of fun stuff, and crazy people are crazy, but you can learn stuff from crazy people. You can learn a lot from crazy people if they're the right type of crazy, and these guys are the right type of crazy. So that's kind of it. That's what I had prepared. What questions did you guys have? Yeah.
I had a question, you talked about I don't use the Arduino quite a bit.
Yeah.
I didn't know what would the reason be, what type of things would someone use a Raspberry Pi? Why would they need a full OS?
So there are a couple of reasons. Some stuff it's just too computationally or storage intensive, right? If I'm making a Roomba needs more smarts than an Arduino can provide. Arduinos are great for thermostats, right? Simple input, simple output. But if you need a complicated learning system, or you need to be able to store pictures, because the Arduinos have 1K of memory, and that's your RAM and your memory, storage and memory. That's it's harder to do some of that type of thing.
Yeah. Arduinos are also slow.
Yeah, Arduinos are 16 megahertz on the high end.
Yeah.
If they don't have the crystal like John had in his server, they'll be 8 megahertz by default. And
Things that
then
those
Raspberry,
even like
you can get like Cortex M processor
Yeah.
ones, which are like that 500 megahertz or so.
yeah.
But a Raspberry Pi starts at like the first version was 1 gigahertz. I think the current version is like 1.4 gigahertz quad core. So Raspberry Pis have a lot more processing capability.
If you need to plug something in with USB, you pretty much have to go with Raspberry Pi.
Yeah.
And
internet.
Yeah. Well, internet is less so. I've done a lot of there are Arduino-based things that you can like that Huzzah, for example, that are like based on the ESP8266 processor and now the ESP32 processor or chip. Those can do internet, but they can't do like browsing the internet. They can do stuff like pinging and like checking stuff. The other thing is that threading. I haven't found any microcontroller thing that is multi-threaded. So if you need to absolutely have to be able to do 2 things at the same time, Raspberry Pi.
The Intel Edison can.
Oh yeah, I guess the Intel Edison probably.
That's
can.
like a $40 chip compared to 3.
Right. There is another class of thing that we didn't talk about here because they're really expensive, but they're becoming more popular, is the field programmable gate array. So it is programmable hardware. So you basically can program a circuit, load that into the chip, it will assume that circuit shape and then like flash it and it stays that way. But those things are like hundreds of dollars. They're awesome for like emulation, like the really high end like NES, that where it can accept a cartridge and play NES the way it was supposed to be played. It's a field programmable gate array that's inside of there that they've done to mimic exactly the circuitry of an NES, because some of those parts aren't available anymore. But if you know what their circuitry was like, there you go. And those are stupid fast. Yeah.
So you mentioned, having blue smoke happen for you. Like any creative thing, I imagine you've had your share of blue smoke and a little bit of discouragement.
Yeah.
Can you just walk us through a little bit, like what that was for you the first time it really happened?
Yeah. So I still haven't fixed the guy. So that would actually be this. So one of the first projects that I wanted to do, that I knew I wanted to do, for my brother's 5th anniversary, I wanted to make a box that would only open if he took it back to where he got married. He got married at like a cool place up in the mountains, but it's a cool spot. It's not like you can just drive there, but it's like a ways out. Like you're not going to go back there unless you have a reason to. So I wanted to give them a reason to. So my idea was like box, GPS, program it with the buttons. They press a button, it'll tell them where to go. If they go there and they press the button, it'll unlock, and inside will be like a bottle of wine and a couple of wine glasses. Right? Cool. Super awesome. GPS, way easier than I thought, way scarier than I thought. So, but this was like my first soldering project. So I did not have the proper tools when I started doing this, and I didn't know what I was doing. So I made a bunch of mistakes, but more importantly, I didn't have the proper tools for fixing those mistakes. So if you want to start soldering, the 2 things you should invest, like outside of like the soldering iron, the 2 things that you should look into, one of 2 things. Either desoldering braid, which is just like a copper braid that basically like you can touch it to solder and it'll just suck it up. Or I use solder suckers, which are just these like syringe-like things. So I liquefy it, push this next to it, and it sucks the solder away. And then like I unscrew this and like little bits of metal fall out. But I didn't have either of those when I started. So when I messed up, I tried to fix it with a Dremel tool. And I can show you the damage that I did. I don't think I permanently broke anything, but I haven't come back to it since. My brother just had his 6th anniversary, so I'm hoping to have it ready for his 10th, but I'm scaling up the project to make up for the lost time. So yeah, so like stuff like that happens. It can be especially infuriating if you run into an issue. We took constructive interference to an independent game festival in South Carolina. And there were dumb problems with it. LEDs, for example, LEDs can take almost no power. So you have to put a resistor in place or you'll just fry them, right? It's like you just give it way too much power and it'll just blow. We didn't know that or do that, so it would like our LEDs would last a little while, but they kept going out, and I kept like having to figure out how to get replacement LEDs in this like town in South Carolina when I didn't have a car. Or like LEDs, they're the RGB LEDs are essentially 3 LEDs, like a red one, a green one, and a blue one, smushed together, and they will be either common cathode or common anode. And if you don't know that they come in both flavors, you will wire it up, and you'll wire it up backwards because they only work in one direction, right? Power has to come in one way and out the other. But if you don't know how they work right, you'll wire it up backwards, and you'll be really angry that like every LED you try, I've tried 6 of these things, none of them are working. What is going on? That kind of stuff happens all the time, and you just kind of have to like futz through it. Google, do some Googling, ask around. Your friends will if your friends know what they're doing and they like to find out about it, they'll kind of laugh at you, but like help you out.
Yeah, a multimeter helps, but you have to kind of do some research and know what you're looking for.
Yeah. I bought a multimeter, I've never used mine.
Helping hands.
Helping hands are actually, I hate those also.
They can be useful though.
Yeah, like a lot of the tools that like a lot of people really strongly recommend, I just like hate. Helping hands is like they're little alligator clips on some sort of bendy arm so that you can like hold things close to other things. Because if you're trying to solder, you're usually like holding a board down, but you also have like a piece in there, but you also have the soldering iron, but you also have the solder itself, and you're trying to hold all this stuff precisely in position in relationship to each other.
I actually use stuff similar to silly putty instead.
Yeah. So different people have different solutions. I just swear a lot and figure it out.
And push things across the table with a soldering
Right,
iron.
but I like doing things the hard way. So. Yeah.
So it looks like you have like a very hardcore soldering iron. You can
Yes.
get like pretty cheap ones
Yeah.
for like $10 or less. I think.
Yep. Yeah.
If you just have
Like
like-
under $20, you can
I have
get
like a $15 one from Micro Center.
I actually bought that primarily, like the soldering iron is awesome and I love it, but I primarily bought that for the hot air gun. Because it turns out I make a lot of mistakes and I have to take a lot of things apart after I put them together.
And that's
So-
really, really good for surface mount stuff.
Right.
So you should mention soldering safety.
Yeah, don't touch soldering irons. It hurts.
Anything metal.
Yeah, they're specifically designed to transfer a lot of heat to a different thing very quickly. Don't set them down. Like, be careful where you set them down. If you start to drop one, just let it fall. It hurts. Yeah, like it hurts. Like the good news, you're not gonna like kill yourself with a soldering iron, probably, unless you like set your house on fire. Like, worst you're gonna do is you're gonna burn your hand really bad, and you're gonna need to like put some clear cream on, cover it up, and it's gonna be sore for a couple of days. Like, it's not the end of the world, but it is extremely unpleasant. You also need to do it in a place where either there's like a lot of space or you've got proper ventilation. The other reason I bought this guy is it's got a suction pump and a filter for the fumes, because solder fumes are not good.
Solder has lead in it.
Yep. So you don't want to be inhaling a lot of that stuff. So, but like if you have a garage or like a big room, like this room would be fine. Like probably solder in here would probably be okay because there's enough air for it to dissipate in. But regardless, yeah. Other questions, concerns? Sweet. Yeah.
Say something. If you're wanting to do the Internet of Things type stuff, there's a thing called Wemos, which is Arduino based, but it has a built-in Wi-Fi card, and it's like $3 or $4. You just have to wait for like 4 weeks for it to get here from China.
Oh, you can get the Linknode D1s from Micro Center right now for $7 a piece, and they're wireless enabled and they're Arduino based. You just have to deal with their terrible documentation.
Yeah, the Wemos ones are also 4 megabytes instead of 32 kilobytes. So.
One last thing.
Yeah.
How much of a pain is it to travel?
So when I
Maybe get on a plane with it.
when I went to the conference, I shipped all of it because I did not want to have to deal with it, which was okay because my company was paying for me to go. Like, I overnighted it because I waited too long to get the project finished, so I had to overnight it, and that was several $100s to overnight all that stuff. But then on the way back, because I was leaving a little early, I told a guy there, like, hey, ship this back. And it took him like a month and a half to finally send it back, which was incredibly annoying. But yeah, I don't know. I haven't really dealt with it. I just avoid the problem by just shipping if I have to. But I'm sure some other people might have had that problem and could probably answer that better than I could. So. All right, I'm going to keep this stuff out until we're like done. So if like afterwards you want to come and talk about specific projects or see where they're at, or like you want to see specific components, whatever, tools. I brought like my whole tool roll. We can talk about whatever you want. So I want to find out what he's been doing.
Yeah, so I'm gonna.
Your stuff looks so polished.
I know.
It's pretty cool.
Yeah. So I'm gonna do like more of a show and tell thing. It'll be pretty quick. But I did a hackathon project where I learned how to do all this hardware stuff, and I learned a couple things that I can maybe put on top of what Jon learned. So I'm going to talk about like some alternatives to some of the stuff you talked about, and then talk about NFC, the things I learned kind of experimenting with NFC. Because if you know what NFC is, it's the thing that Nintendo uses in Amiibos. The thing that, do you want to turn the camera this way, or like
Just to rotate the chair.
somehow? Okay.
Should be good.
Here, I'll move forward and show stuff off. Like Skylanders use it. Even like Lego Dimensions figures, if you've seen those. So those are all using NFC, which is like kind of like low power RFID. The point of it is to keep the power real low and keep it real cheap. So NFC.
I broke it.
You broke it? An NFC, like, whoa! Even these little stickers are like NFC tags. So you can put them anywhere and then read those things and write to them. NFC is lower power and does less than like RFID in general. It's like a dumbed down spec. So you can't store that much on them, and the security is really, really super low, which is why you can buy things like Zelda figures on cards that are actually like Amiibos that people pirated from Nintendo, because it's just there's not really any security on it. You just kind of have to copy. I probably shouldn't talk about that. but you can do, it's really easy to like mimic things that are NFC. So I'll start with kind of the components that I used to make this thing. So this is the thing that I made as a hackathon project was with a couple people, and if you know Evan Cobb, we worked together on it, and a couple other people. We ordered a starter kit, kind of like what Jon has. This one did not come with any documentation, but it came with a link to a PDF that's like has like 40 projects in it that are documented in fairly good English. And this came with a whole bunch of pieces. The one that I really cared about was it's like a NFC ready like starter kit. So if you have something specific you want to do, you can pick up a starter kit that targets that specific thing. And it has all the pieces in a simple project, which is what I wanted because I had no idea what I was doing. But I figured if I can get something that works a little bit, we can move out from there. So if we open this, can you see this from back there at all? I'll move it up a little bit. So this is the Skylanders base, and we unscrewed it, took it apart, and put all the crap in there. So the thing on the top actually reads the NFC, and then the thing on the bottom, this little microchip, is the coolest Arduino I've ever seen. It's not an Arduino, it's a Photon Spark, but it is a network-enabled, like out-of-the-box Arduino, and there's an iOS and Android app. You download the app, and you use it to configure the Wi-Fi on your Photon Phaser, whatever it's called. And then once the Wi-Fi is configured, you can go to this website, code right there, hit a button, and the Wi-Fi will actually send the code down to the device. So you don't, like, this is connected via USB, but if I run something on it, it won't actually talk directly to it through USB. It's all going through the Wi-Fi. It's really super cool. But that made doing things like iterating, writing code, and sending it to it a lot quicker. And debugging it is easier because there's a little button that lets you check to see if it compiles. And if it does, then you're good. If it doesn't, then...
The Arduino has that also.
Yeah. So this is plugged in, and it's on, I think. Let me see. Yeah. So the way that this project that we built works, and it's going to be hard to see without the camera closer, but
I can't move my
I
laptop
think
much.
I can move my laptop over here.
You can set it on the chair and just tilt the camera down.
Yeah. So I'm going to take one of these things. I'm going to take this and take one of these guys. So this is a happiness cube, and it's a cube that's covered in NFC tags on each side. So how this works is you choose a persona for yourself from like any sort of amiibo or any sort of like off-the-shelf like toys to life figure, and you put it on there, and it reads it, and it said red because you're not supposed to read this guy first. You're supposed to read this guy first. So put that on there. And shoot. That might have knocked something loose. Okay. Well,
Live demos.
live demos. So it should show a little green light. And then you put your figure on. Yeah, it's not reading the oh, okay. Let me try this. It's still red. Put this on. That worked earlier. Okay. So you put that on and it reads in the feeling. You put this on. No, wait, that's red. So I might. Okay. Well, it used to work earlier today. But you put this guy on and it would turn green. You put this guy on and it would light up both lights and make a request and send like the figure that you had and the feeling that you had, and send it to a web service that will update that specific figure's number of times that they've registered that feeling. So this person has had ecstatic 3 times, happy 4 times, and you can use this to track a team's happiness. So that was the idea. It worked really well. Whatever. But I can show you on this, and I can show you some other things about NFC that's really cool. If you want to figure out how NFC works, you have an Android device. There's an app called NFC Tools, and NFC Tools is an app that lets you essentially read any NFC figure, and it will give you like every possible piece of information about that figure. So you can figure out what the tag ID of that figure is. Yeah, like a lot of information. You can actually write to it with specific values, and then you just put it back on and tell it to read it. It reads everything back in, and it basically lets you configure any like NFC tag of. There's a bunch of different types, but it'll tell you what type that is also, and you can try to match it with whatever you're trying to do. And it lets you. It does a really, really good job. The other thing, so I wrote that same app for Android, and since Android has NFC, I can take my cube, read the feeling. So I'm choosing angry, and it will select it for you and send it to the service and change it to yellow for yeah, and it does happy. So this is just, you can also just swipe left and right. But yeah, built all that stuff just to kind of learn how NFC and hardware work. And I guess the big takeaway I learned was that Spark is a really, really good way to get started with it. I would say in some ways it's better than Uno. Because, I would say Uno is a really good way to get started because all the documentation is around that specific pin configuration. Spark has the same pins, but they're in kind of different places, so you kind of have to infer that yourself. But being able to like take that and push go to it through the internet. It makes it really, really easy to get started. And what else? So that's part of my show and tell. The other part is John didn't really walk through this, but this is
The touchscreen thing.
yeah, touchscreen thing. There's just an Arduino Uno in the back, and then you can get a touchscreen.
Pi with Raspberry Pi.
Yeah, it's a Raspberry. No wait, yeah, it's a Raspberry.
Yeah.
That's a Raspberry Pi in the back, and then you just plug it in, and this is a touchscreen. And you can do stuff. Yeah, this was a lot more complicated to just like have an idea and do it, because there's just a lot more involved. But you can play Minecraft on it, just by installing the thing on it. It's kind of crappy Minecraft, but yeah.
Build a new cluster, and
Yeah.
a bunch of other ones.
And the other thing is, if you're like aesthetically minded, you can buy cases to this stuff and make it look prettier. Same thing with like the screen and the mount; those are both like made to fit with each other, and then everything just looks like it was meant to look instead of like jumbled wires and stuff like that. So yeah, that's pretty much all I wanted to talk about, because I just think the stuff I learned for NFC is really cool. And if you're interested in that, you want to make a game, having access to that app teaches you a ton about it, just like by scanning stuff and seeing what comes up. And just the weird ideas that you can come up with once you start doing that is the other thing I want to kind of like, I guess, impart on everyone. It's like, if you're not bound by a screen, you can come up with a lot of crazy stuff. You just have to think of like sensors and different types of input, and then just think of how output. It's like, if you boil games down to their essence, it's like, what Pong is like the input of moving up and down and having a reaction. And that's basically like not being bound by buttons or a touch screen. Like, you're bound by anything physical, and you can turn that into a game. And doesn't even have to have a screen or a scoreboard, just like being able to kind of have a reaction when you do something. So yeah. Does anybody have any questions about this stuff?
Were you able to actually read any information off the amiibos, or just get the ID?
If you scan the amiibos in the app, you can get all that stuff. I didn't do enough research to like figure out what all is coming back. You basically scan it and you get a big string of letters back. And that stuff probably like decrypted in certain things. But I didn't, to do my project, I didn't get to that way. So yeah. If you scan one in here, you can see tons of stuff now.
Roughly how accurate is this? So like if one wanted to download physical tic-tac-toe, detect position?
It doesn't detect position.
You could put 9 sensors down, and then each sensor would read it.
Yep.
And then you could have an ID for each thing, so that you can't have it on multiple spots at the same time.
Yeah, for tic-tac-toe you can do that. If you have one thing, you could put the sensor in that thing and send that up wirelessly somewhere. And then you could make the board with different NFC tags on each spot. But it wouldn't be tic-tac-toe, the board needs to be the one sending everything, because you have so many other pieces.
We did, my company for a conference made an NFC-enabled Connect 4 game that hosted all the game online as people play. And like that type of thing, that's pretty easy to do.
I've also seen people do the stickers like in their car and at home and in their bedroom. And when they put their phone in certain spots where they swipe it, it turns it into those modes. So it turns on your audiobooks when you're in the car. It turns on your apps for your whatever when you go to bed.
Yeah, that's a good point. Another thing you can use this stuff for is like, instead of buying off the shelf like smart like doorbells and like smart lights, you can build them yourself with like very little like of your money, and like there's stuff out there to just like throw it all together. You don't have to write code, you just have to steal it.
or if there's a smart device you want that doesn't exist. Like one of the projects I'm working on right now is an Arduino doohickey. This is my car, has a SIM card, so it has cellular access and GPS unit. And anytime the car stops, it does a quick GPS check, checks to see if I'm at a parking meter. If I am, it uses the SIM card to access the internet, and basically, like, I've got money reverse engineering the pay the parking meter app, and it'll just constantly pay the meter the minimum amount as long as the car is parked there, so that I never have to worry about parking tickets again. I can just like park wherever, and it'll just pay. But like, it'll pay for like 5 minutes at a time, so I'll always pay for like exactly what I need.
What else the battery wears out?
Yeah, well, it's probably gonna be powered by the car. I would Prius, the whole thing's a friggin' battery, so.
We all have our battery lasts like 3 years.
Yeah.
Or more.
That's awesome.
So yeah, I'm gonna try this thing. He doesn't read. He doesn't read. Oh, is it? All right. Well, whatever.
Make sure I turn it
Oh wait,
off.
I see the green now. I think it was working that time. You just can't see the light. Here, I'm gonna take this off. I'm gonna put the cube on. Okay, the green is lit up. Oh, you can't see it because of the thing. Okay. Move this back a little bit. No, you have to move that down a little bit. Okay. There's a green LED lit up. You just couldn't see it because of the light. So now I'm gonna put my finger on, and it's sent it. Sent the request through. So if you look at the website, you'll see like the thing bounce to show you that it's been sent. So I'll take the cube again and choose like send, put that down. Come on. There you go. Now I'll take this, take this guy again, and whatever. I think my finger's on it. Yeah. So now it's working. So it's posting a request every time it scans two different things. And if I would scan this guy first, it flashes red to show you that it didn't work right. So with just like two LEDs, you can communicate all the different states of the game. It's pretty cool. So, yeah. Okay. Does anyone else have any questions for either me or not?
When you're done, I was thinking about doing a like 2-minute impromptu thing I thought I would present that relates to the scanning time.
Cool. Unless anyone has anything, we'll be up here to talk about this stuff. If anyone has any questions. Okay, go for it.
Okay, so while I was watching Wes do the scan with the block to detect whether it's happy or sad and possibly assign it to a character, I'm going to try to show this to the camera. This is a physical trading card. It's a Flame Magus, and it's for the Eye of Judgment from PlayStation 3. It was several years ago. First, what happens is it's a video game, so you're playing with a PlayStation controller, but it actually uses physical cards, and that's why I have these. And so what it first will do is it'll look for, with the PS3 eye camera that could be USB plugged into the PlayStation 3, check for the 4 green triangles, and if it can detect those clearly enough, when the camera is just aimed down at a little mat pad with 9 spaces for cards on it, then it'll try to read the black area. And the black area is pretty much like a barcode of its own fictional language that they invented for the game or something, and it'll tell the game what the card is. So you'll play these cards on a mat, 3x3 grid, and when the card is placed down, there's a faint transparent overlay of the actual map on the game screen. And when that happens, and the battle starts, it'll have the actual digital graphics of the game and everything on there overlaid as well. So you put these cards down, there'll be a little circular clock-like dial that goes, and if it scans right and it's good enough quality, it'll then summon the card on the screen with a 3D graphic of the monster. It'll be a dragon or a tank. This is a flame warrior that can attack any space. So Wes made me think of this when he mentioned the scanning tech, and this can be used, I figure, both for these little Arduino projects, potentially with scanning, or Raspberry Pi, as well as with full-fledged game development. I believe this was something Wizards of the Coast actually did, and they proved that you can actually take physical media that isn't necessarily a 3D object, but also just a card with your own barcode system, and it can scan something and output anything from a little text to a full 3D character on the screen, or even a battlefield for all I know. So I just thought that'd be something to add impromptu. That's some pretty awesome tech.
You guys want to?
Yeah. Yes, that stuff.
Okay, you want to do that?
All of them? Yeah,
I can.
All right, so we have lots of events coming up. Starting, this is a bit late notice, but I just found out about it myself. It's the Twine Jam. Pixel Pop is hosting this at the St. Louis Public Library tomorrow night from 6 to 8 p.m. And with a max of 24 registrants, I'm pretty sure there's still spots open. You can just check out the Twine Jam through Facebook, I believe. And what they're doing with Twine is it's an interactive, you can make like text adventure kind of games or point and click, very basic stuff. But that's an interactive thing they're doing there. After that, we have this Thursday will be the Drink Up, July 13th from 8 to 11 p.m. at the Orbit Pinball Lounge, like usual. You can chat, drink, play games if you want, and we'll have raffles for swaggy stuff throughout the evening. So there's all kinds of stuff you can do there, so people even go there and like draw while they talk to people. So after that, we're going to be trying to move. We'll actually be moving our monthly events, not the Drink Up, but these topic-based events to Tuesdays instead of Monday nights. And the first case of that will be Tuesday, August 1st. What we're doing then is going to be how to improve the game development scene in St. Louis, making game development more successful, look at what the challenges and the roadblocks are. So we'll be engaging with you guys and trying to identify what some of those largest hurdles will be, what makes it more difficult, whether it's financial stuff, cost of renting places or services, how to get your games exposed, whatever those topics might be.
Yeah, I can talk a little bit more. So the point isn't just to like talk about what the challenges are. The point is to brainstorm on solutions. We're going to do lean coffee format, which is came out of the Agile community. It's a way of like keeping the room involved in the discussion. So it's not just going to be sitting and listening. It's going to be us all kind of giving ideas, like pinpointing what the issues are, and coming up with different solutions that we as a community can take on. So yeah, it should be really should be interesting. And if you want to help us try to solve some of the problems, or like maybe identify some problems that we don't know about, you should come on August 1st and talk about that.
And that'll be here, same place. Next thing will be the First Friday event on August 4th, excuse me. Up to 3 demo tables will be available with up to 6 individuals or small teams, so about half table each is guaranteed to you. If there's less than that, there may be a chance to use the full table, but don't count on that necessarily. There's mostly going to be kids there, but there are some adults that pass by as well. Even some of the parents take interest. I've done this 3-4 times now. Snarf, I think, was just there this past Friday, and we've been trying to promo that, and there's a lot of fun little games. Even if it's not necessarily aimed at kids, you might get some good feedback, even from the little ones. I learned some interesting things myself. So First Friday is currently one of our leading ways to have regular demo opportunities. Even though it's not a specific demographic, there's so much traffic, you should be able to get something out of it. After that, right after that, is Pixel Pop. We've been talking about this for a while. This is August 5th and 6th, right after the first Friday. I'd like to ask if anybody here is planning to do a demo at Pixel Pop. You can talk about what you're going to be doing.
I'm building a big scary thing.
That's good.
Big scary thing. Lots of wires. Lots of buttons.
Is
But you don't have to ship this one.
Oh, also,
Yeah, I'll be speaking. I have a booth. Well, I help out one of the developers for a drawing and painting application. So I have a demo booth, I guess, showing off some of the new features in it and some of the stuff as well. And I'll probably, the name of the program is called Krita. It's for digital painting. It's more for like custom artists, video game art type stuff. And I'm doing a talk on, something about staying motivated as an artist and just trying to have different resources to stay motivated and kind of become better.
All right. We're past the registration point for that, but there are going to be some local St. Louis people there, as you've just seen. Also, we, the co-op, will have a table there as well in the expo hall, I believe. And we'll try to have some signage up there and actually broadcast the co-op a little bit to all the passersby as well, outside of just our community. So we will be, if I'm right, Wes, we were going to try and do rotating demos for people if they weren't able to get a table space. We still need to talk about it more and get the details ironed out. But
did anybody have a game that they wanted to demo but they didn't get in there in time, or like didn't want to commit the whole event? So, we're gonna have some table space open where you don't have to commit to the whole event, but you can come sit up there for a couple hours and show off your game, get some feedback. Yeah, it's just a way to help out people that didn't quite make it in time, and like it's give you a reason to be a co-op member. You know? So
that's all we have for now. Are there any questions about the? Yes.
Does it need to be played?
It depends. You could set it up for an hour to get feedback on the concept or things like that. I think that'd probably be okay.
That should be fine.
Just submit online. If we get a whole bunch of like submissions, it might kind of drop off. But yeah, but definitely sign up if you have.
So the majority are.
Majority of games will definitely be playable. Yeah.
Any other questions? Yes.
Yeah, where will that be?
The
Yeah, Pixel Pop.
It's at. Is it
Yeah.
Yeah. Go to pixelpopfestival.com and it has all the information. And you can, I think, if you get tickets early, you save some money. So if you know you're going, go ahead and buy it like this week before you show up.
their address should also be on the Facebook event page as well.
Okay.
All right. Well, if there's no other questions or comments, that concludes tonight's event, and we're really glad you came. So thank you.
Yeah. Thank you very much again to Jon Leek. And as always, thank you, Ryan.